All right, we are now looking at 7C.2, which is very similar to 7C.1. We're still kind of looking at how similar triangles and trig ratios go together. Okay? So our 7C.2 MLO is I can determine if two triangles are similar by identifying their trig ratios. So this is just, basically it's just the opposite. Before, we knew their trig ratio, we knew they were similar, and so therefore we could find their trig ratios. Now I'm going to know their trig ratios. I'm going to say whether they're similar or not. So looking at example 1 and 2, I just want to prove that the following trig ratios are congruent. So I'm going to start with the sine of A. And we're still using our lovely SOHCAHTOA. Okay, so sine of A is up here. Okay. Sine of A is going to equal opposite over hypotenuse. So if I have my right angle, I have my hypotenuse, across from my angle is my opposite side, and then my adjacent side. So the opposite side is 48 over 84. And then I'm going to check to see if that reduces. And it reduces to 4 out of 7. Now I need to look for sine of H. And there's H, so I have my hypotenuse, the opposite side, and the adjacent side. So again, sine is opposite over hypotenuse. My opposite side is 8. My hypotenuse is 14. 8 over 14 also reduces to 4 over 7. So, sine of A is equal to sine of H. All right, example 2, same thing. I'm going to start with cosine of A, which is flip-flop. A is over here. All right, so I have my hypotenuse, the opposite side, and the adjacent side. So now we're looking at cosine of A. Remember, cosine, I'm using this as adjacent over hypotenuse. My adjacent side is 4. My hypotenuse is 5. 4 out of 5 does not reduce. Then I'm looking at cosine F. Here's F. It's my opposite. Hypotenuse. Adjacent side. So cosine of F equals, again, cosine is A over H. My adjacent side is 16. My hypotenuse is 20. And then if I reduce these, I do get 4 out of 5. Bad 4. So again, I can say that these are equal. Cosine of A equals cosine of F. And so that's all I'm doing. I'm just proving that those are equal. All right, let's look at example 3. Given the right triangles, answer parts A and B. So A, find the sine ratios of the corresponding non-right angles. Okay. So I'm starting with the sine of A. Well, A is here, so I have my hypotenuse, my opposite side, and my adjacent side. So, sine is opposite over hypotenuse. If we think back to SOHCAHTOA, this is so. My opposite side is 15, and my hypotenuse is 17. And that does not reduce. If we look at B, okay, well, this is B. So again, remember, I have to relabel my sides. Hypotenuse gets to stay the same. Across from B is my opposite side. Between them is my adjacent side. So sine of B, sine is still opposite over hypotenuse, but from B, 8 is my opposite side, and 17 is my hypotenuse. Okay, so sine of A is 15 over 17, sine of B is 8 over 17. I'm going to do the same thing with my other triangle. I'm going to find the sine of m. M is here. So again, I have my hypotenuse, the opposite side, and the adjacent side. So across, so sine of m is opposite over hypotenuse, so opposite of m is 30. The hypotenuse is 34. This does reduce to 15 over 17. Now we have to do the same thing with sine of L. Again, since I'm switching my angles, right? Luckily my hypotenuse is the same. Opposite side, adjacent side. So my opposite side is, so sine is opposite over hypotenuse, which is 16 over 34. That also reduces to 8 over 17. All right, looking at part B, it now says, explain how your result supports the triangles being similar. Well, again, if triangles have equal trig ratios, then they are similar. So, the triangles are similar because the trig ratios are equal. All right, these ones are equal and these ones are equal. All right, let's look at example 4. This is more like what you would see on the test. It doesn't give you as much information, right? So find the sine ratios of the corresponding non-right angles. Are they equivalent? So it doesn't tell you exactly what angle you're finding the sine ratio of, but it's the non-right angle. So I have to find both A and then B. Okay, so for this question, you have to do 2. So I'm going to start with the sine of A, which equals opposite over hypotenuse. So again, we have our hypotenuse, our opposite side, and our adjacent side. So my opposite is 12 over 20. That does reduce to 3 out of 5. Now I need to do my other angle in this triangle, right, just like we did before. So again, I have my hypotenuse, I have the opposite side, and I have the adjacent side. So, sine of B, right, is also going to be opposite over hypotenuse. Now my opposite side is 16, hypotenuse is still 20, and that's 4 out of 5. Now I have to look at my other triangle. Okay, so same thing, I'll start with X. My right angle is here. So I go across my hypotenuse, opposite, adjacent. So sine of X equals opposite over hypotenuse. My opposite is 4. My hypotenuse is 5. That doesn't reduce, right? Now I have to do my other angle, Z. Okay, so again, across from my right angle is my hypotenuse. Across from the angle is the opposite, adjacent. So sine of Z is opposite over hypotenuse, which is 3 over 5. Okay, so then again, our last question here for B is explain how your result supports the triangles being similar, if they are. Right? Well, they are. Look, it's not exactly across, but I do have these are equal and these are equal. So sine of A equals sine of Z, and sine of B equals sine of X. Okay? So again, the triangles are similar. Because the trig ratios are equal. All right, that's it for B2. Go ahead and work on your activity.